Good afternoon, majors. I am going to finish up the quadrilateral note today. So then the last video you listened from Mr. Sherbob ends right before he finished. He talks about mid-segment of a trapezoid. So I am going to finish that today and then do the day 5 or day 6 of the note. So what is a mid-segment? A segment that joins the midpoint of the side of the trapezoid. What it means is, so as long as I have a trapezoid, so this is the midpoint of this AD, that means it's going to cut it in half. And this is the midpoint of BC, that means this segment is going to be equal to this segment. So if I create a line connecting the two midpoints, so this point, this line that I just created is called the mid-segment, okay? This is the mid-segment of the line, so this is called mid-segment. Okay? I can't see mid-segment. I guess it is. Okay? Here. Segment of the trapezoid. So this is the line that is represented to be the mid-segment of this line. Okay, that's what the mid-segment is. All right, so now is the mid-segment of this trapezoid ABCD. What is the property of the mid-segment? One is the mid-segment is parallel to the base of the trapezoid. So as you guys can see, so I'm gonna move this away. I guess let me delete this out so that you guys can see. So then this line AB and DC are going to be parallel, right? Because it's the base, it's a trapezoid. And this line is also going to be parallel to the two base. So that's one property. The second property is the measure of this. So let's say ED, in this case EF. Let's label it EF. So the measure of EF is half of the sum of the base. So what it means is EF is going to equal to 1/2 of base 1 times base plus base 2. So 1/2, so base 1, B1 plus B2. Okay? B2. So which one is base 1? This can be your base 1. Doesn't matter if you label this as base 2. Doesn't really make sense. That's base 1. And this is going to be your base 2. So when you add this divided by 2, you get the measure of the mid-segment, which is EF. So let's look at a couple of examples. Find the value of x. So I'm looking for the mid-segment, right? So my formula would be the mid-segment is 1/2 of the sum of the two base, right? X is 1/2 the sum of the two base, which is 7 plus 11. Okay? 7 plus 11 divided by 2 would be x. So x would be 7 plus 2. 7 plus 11 is 18, right? Half of 18, which is what? 9. Yep. So x would be, the measure of x would be 9. Okay? So that's 9. Right, the second one is the same thing. So I'm going to skip number 5. You guys can figure that out. Add up the two base, divided by 2, you get x. This one's a little bit tricky, right? They gave you the mid-segment to be 8. Okay, so I'm going to do 6. So 8 is given to be a mid-segment, right? And then base 1, I don't know, it's going to be x. So 1/2 x plus base 2, which is 12. So what I'm actually teaching you is what the formula is and how to set it up. Solving for x in a fraction comes from your Algebra 1 skill. So a lot of you, if you get stuck here, it's not the geometry that's bothering you. It's the algebra that's bothering you. So since it's multiplied by 1/2, if I multiply both sides by 2, it would get rid of the fraction. So 8 times 2 is 16. 1/2 times 2 is just 1. So I have x plus 12. Okay. Then I have to add up minus 12 from both sides. Minus 12 from both sides. Which gives you 14, right? 4, I'm sorry. So this is going to be 4. So is it true? 12 plus 4 divided by 2 should give you 8. 12 plus 4 is 16. 16 divided by 2 is 8, right? So that's the way it goes. All right, so you should be able to finish up the rest of the package once I finish with this. And then the last one, 8.7, is coordinate proofs with the quadrilateral. So this is more of you plotted, you kind of determined. If when you can't, then use the properties of slope or distance to find what it is, okay? So say position figure, use the original as its vertex or use the origin as the center of the figure. That's some of the procedure. What are you going to be learning here will be you'll be able to position and label quadrilaterals for using coordinate proof, and then you'll be able to prove theorem using coordinate proof, right? Place at one side of the quadrilateral on an axis. Try to keep the quadrilateral in the same quadrant if possible. Use the coordinate of the coordinate that makes the competition as easy as possible. For example, use even numbers if you going to be finding midpoint, okay? Name the missing coordinate for each quadrilateral is the question, right? So in this case, it's kind of, kind of common sense. I know, and it also tells you here, it's a rectangle, there's a isosceles trapezoid, and this is a square, right? So what you know is the x coordinate is going to be here, right? And then the y coordinate is going to be here. So far, I know this is 0, 0. This is 7, right? 0, right? 7, 0. Because it went 7 units, so you have to go 7 units again. Since you didn't go up anywhere, it's just going to be 0. From here to here, x did not move, so it's going to be 0. But y moved from 0 to 7. So that's all you have to do. Trapezoid, when it comes to isosceles, it's a little bit tricky because you want to kind of create your rectangle inside it so that you know. So this measurement is pushed 3 units. That makes this is also 3 units. Okay? So what is the coordinate of this number? So the coordinate of this number is 12 and 0. So this is going to be 12 minus 3, which is what? 11, right? And 0. No, not 0, sorry. 5. All right, let me erase this. Because this coordinate here is 5, 11, and then this coordinate here is going to be 5. So I'm going to put 5 here. Okay, so the square is not going to be difficult, right? A0 is here, so this is going to be negative A0, right? Because it's in the fourth quadrant. Negative 8, 0. Okay, going up is going to be negative sorry guys. Then the B part, there you have to kind of, okay, from here to here is what? So you got to kind of try to differentiate. All right, the other type is professionals positions and label each quadrilaterals on the grid below, right? Square ST UV with the side units S. So how would you draw that? It's a square, right? It's just an easy, I can even pull my picture and then just, this is a square, right? And then we'll do STUV. So you can label it in any way you want it. You can do S, T, U, and V. All right, that's going to be a square. Parallelogram PQRS with congruent diagonals. So now I need to create a parallelogram with a congruent diagonal. So that means it needs to look like a square. So you just draw it out and then figure it out, okay? So these are the lessons you guys need to know for this unit. I will be back hopefully on Monday or Tuesday, and then we will continue finishing your review. So don't forget to do eCard practice test. Don't forget to do the review package from the assignment that I gave you. All right, have a good day.